In this video, I build the fetch register on breadboards. While it looks like one of the general purpose registers, I do make a mistake and end up burning my finger a little bit. Look for that. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. So in the last video, I put together this circuit, and what I've done off camera is I added in my temporary address bus 1 here. So this then takes the output from asserting onto address bus 1 off the register, passes it into this bus, which is nothing more than a connection point, and then onto my stand-in for my temporary memory module, which is then just taking the same thing and displaying it. This would then be where I'm going to connect in my fetch register. And today I want to actually start putting that fetch register together. So I'm going to pull this out and set it aside. And I'm actually going to move this up here. And with this circuit, there actually is no power and no ground that's being pulled. So it really doesn't matter. But what I have done is I've put together some breadboards to house my fetch register. And this will be the focus of my attention today. Now, this is going to look an awful lot like this register once I'm done. So I'm not going to spend a whole lot of time actually talking about what I'm doing. And as a matter of fact, if you go to the register playlist, you'll see the entire design of this and how it all came to be. But a lot of it's going to look very similar. The first thing I'm going to do quickly is add in some bus lines, which will bring these signals down to the bottom here. Well, wherever these end up being, I'm going to have my inputs into the fetch bus be down here. So here we go. Yikes. Okay, that's not good. That one I put in backwards. That's a goner. I don't know if you can see it, but it got so hot it actually melted the breadboard. I may have to swap out the breadboard as well. We'll have to see how that works. Okay, so that's effectively the fetch of the fetch register. And I'm going to replace these temporary wires now with permanent wires. Alright, well that tells me that this location on the breadboard does not appear to have been horribly damaged. Let's see how many I can actually get plugged in. That looks good. Okay, so that then is the fetch register. The only challenge I'm going to have at this point is going to be a reset, where I don't have a way to reset this fetch register down to a 0 value. And what I believe I might need to do is put some pull down resistors here on the actual D-type latch itself in order to make sure that that reset happens properly. And I think I probably need to just go ahead and do that now. So let me work on getting that done. Okay, this then will give me the ability to not assert anything onto the fetch bus and then force this to load, and it should load a no op. So let's try that real quick. If I turn that high, I'm loading 0 in there. Back to low, I'm loading whatever's being asserted. So that'll give me the ability to get a clean reset as well. Next up, we'll be building the instruction register on breadboards. With that comes the start of the control logic. Some definitions need to be put to that and how everything is going to interoperate given the machine instructions that are going to be passing through the instruction register. I do still have some things left on the to-do list, and those are scrolling through up there in the corner.